Hey everybody, Carl here from WireGuys, and I'd just like to welcome you to our new series on electrical control. We're going to be covering everything from direct online, star delta starters, sequential starters. We're also going to be having a little bit of fun with Arduinos, and in this first episode we are going to be breaking down the electrical contactor. Hope you enjoy. So before we start disassembling this contactor, let's just quickly take a look at it. Okay, so this is just a little breakdown on the side here to show you what all the contacts are. So 1, 3, and 5 is your line side, and then 2, 4, and 6 is our load side. So what that means is our line, which would be the cable or the conductors feeding this contactor, would come into our line side, and our load side going to either our motors, our lights, or air conditioning, or whatever it is that you're feeding with this contactor, would be connected to your 2, 4, and 6, which would be your T1, T2, and T3. Then you'd have your A1 and A2, which is your coil connections. This particular contactor is fitted with a 220 volt coil, and then it shows us our kilowatts here. So if you're running this on a single phase load, line and load side, you can go up to 11 kilowatts. If you're running 3-phase, anywhere from 380 to 415, you can go up to 18.5 kilowatts. Okay, then let's turn it over. So the 1, 3, and 5 over here is what we just saw there on the side on the nameplate, and the T1, T2, and T3 is over here, which is our load side. Then we also have two auxiliary contacts, a normally closed and a normally open. So NC stands for normally closed, NO stands for normally open. Now what that means is, in this contactor's de-energized state, that means no voltage is running through the coil, and the contactor is not pulled in. So in other words, it's not in its energized state. That means that we will have on our two contacts here, there won't be any continuity through there because that's normally open, and our other two auxiliary contacts here and here is our normally closed. And if we test that with a multimeter, that means that we will have continuity through the normally closed. I'm going to now put some power onto this contactor, just onto the coil, and then we will do some tests so that I can show you how it all works before we start disassembling this contactor. Okay, so I've now wired up the coil here to A1 and A2. I've just got it running through a circuit breaker. So if we now energize it, you can hear the contactor kicking in and out. So let's leave it energized there. Now the coil has pulled in all the contacts, and the contactor is energized. Let's de-energize it, and let's run some tests. Just going to put my multimeter on continuity. That simply means you'll hear a beep when my two leads touch each other. Okay, so like I said, your L1, L2, and L3 would be your phase 1, phase 2, and phase 3 in a 3-phase setup. So that means that we will have our red phase, white phase, and blue phase. That's typically how we wire them up. And L1 goes to T1 when it's energized, L2 goes to T2 when energized, and L3 goes to T3 when energized. So you have your power up here, contactor's not energized, that means we won't have any power down here, and that means whatever it is that you're running, whether it be a motor or something like that, it won't run. Alright, so we can do that test quickly. We're not getting any continuity there, no continuity there, and no continuity there. Right, let's energize the contactor. Right, now between L1 and T1 we have continuity, but you won't have between L1 and T2 or T3 because it works like this. Okay, so we will have between L2 and T2, and we will have continuity between L3 and T3. All right, then let me just de-energize it again. Now we can talk about our auxiliary contacts. Okay, so with contactors, I like to separate my mains circuit from my what I call a control circuit. Okay, so your normally open and normally closed auxiliary contacts, we normally use them for our control circuits. So that means that we will use them when we wiring up things like direct online starters, star delta starters, forward and reverse control circuits and things like that. And those are all circuits that I will be going into in detail in this series of videos. But I do feel like it's important for you to understand the contactor first before we move on to those control circuits, just so you have a better understanding of how a contactor works and why we wire things up the way we wire them. So between the normally open contacts, like I said, in a de-energized state, if I test between the two normally opens, we are not going to have continuity because it's normally open, and de-energized means it's in its normal state. Then between our normally closed, we will have continuity, and I can show you that there, and we have it ringing out, right? That means that the reason for that is they are normally closed. So the contacts between the two normally closed connection points are making contact because it's supposed to be like that, because it's in its de-energized state, in its normal state. Now, when we energize it and we test between our normally open contacts now that the contactor is energized, we will have continuity between our normally open contacts. And we will not have continuity between our closed contacts. Now I've de-energized it. Let's quickly do the normally closed again. And there's our continuity and our normally opens. No continuity. Okay, so most contactors are set up like this with our line and load side and with our normally open and closed. Some contactors will have 2 normally open contacts and 2 normally closed contacts. Some will have 3. You can also get auxiliary blocks that you put onto the accessory clip over here in the front. You just simply slot it over, and you can have more auxiliary contacts, and that will be determined on what kind of a circuit it is that you're building. You also get timers, on delay and off delay timers with auxiliary contacts that go into these contact blocks, but I'll save all of that for future videos. The purpose of today's video, again, is just to understand the contactor and exactly how the contactor works. Okay, so now I'm going to remove the power from the coil, and we will then deconstruct this contactor so that you can see exactly what's going on in the inside of this contactor. Guys, let's start the teardown of this contactor. First thing I'm going to remove is this little dust cover for the accessory clips here. Like I said, this is where we put on the accessories for the contactor. That's what we'll explore in future videos. Then I'm going to just remove these little terminal covers with the labeling on it, and that reveals our three L1, L2 and L3 terminals, and this is where the connections go into. Same with our T1, T2 and T3 terminal cover. That off there. Right, then I'm going to just start removing the front faceplate. Okay, and then that reveals our contacts on the inside. So as you can see, the contacts move back and forth, and those contacts there, when the contactor is energized, makes connection and gives us continuity between these 3 points here. It's a little bit difficult to see on camera, but here is our auxiliary contacts. The other one is further back inside, and it just makes that a little bit difficult to see, but same concept applies to our auxiliary contacts in the side of the contactor. Remove these two screws over here. Get the right screwdriver. That one. Okay, I'm now removing the contact block. Take out those two screws there. Okay, and then this is our contact block that houses all our contacts, the ones that we just spoke about now. And inside here you can see what we call an iron core or magnetic core. And the other half of the magnetic core sits inside our coil housing over here. Now, this section over here is our coil. I can remove the coil from the housing. And here's our coil. So our coil is an electromagnet, which means you apply voltage. And this is a 220 volt or a 240 volt coil. And if you apply your live and your neutral point here, you're energizing the coil, and it creates an electromagnetic field which makes the two iron core pieces attract to each other, and that is what creates our opening and closing on the contact block. Okay. Then we have a retention spring, which is just in place to push the contacts back forward once the coil is de-energized, just to make sure that we don't have any connections between the contacts. Then I can remove that part of the core, and there's our iron core there. And then we have the base plate. Now the base plate is equipped with a little clip, and this clips onto a DIN rail mounting bar. And if the contactors are too big to obviously mount on DIN rail, then it will normally come, the base plate will normally come with mounting holes. This one also does have mounting holes over here, so that if you are not using a DIN rail, you can simply just use nuts and bolts to mount this down onto the chassis plate of your DB. All right, now let me just talk about the coil a little bit more. The coil voltages come in different voltages depending on what voltage you require for your control circuit. Common voltages are 12 volt, 24 volt, 110 volt, and what you use to determine the size of your coil or the voltage of your coil is the type of control circuit you're using. So generally with PLCs, you'd use a 24 volt coil. You could use a 380 volt coil as well if there is no step down transformer, or you don't have a neutral in your DB, or if it's for a direct online starter, then you will have a 380 volt coil, which you simply would use the 380 volts that you're feeding your circuit with to energize your coil. But at the end of the day, this is what you use to energize and de-energize the contactor, and that is a very crucial part of a contactor. Without this, the contactor will never work. We generally, with contactors, wouldn't suggest tearing them down this much. You would only open up a contactor to maybe replace a burnt out coil. If the contacts on a contactor are burnt, closed or shut or together, then we normally replace the contactor with a new one. And like I said, the only component we really would suggest changing on a contactor is the coil. Right, and so I think now we can go into the factory and I can show you some examples of where contactors are installed and where we use them. All right, so here is our first example machine that we're going to run a contactor on. This is just a wood shavings machine. It's got a few motors on it, but I'll just run one of the motors so that you can see what is happening. So this is the control box for this machine. As you can see, it's got 4 starts and 4 stop buttons there. We will just be running the belt on this machine, which is that conveyor belt over there, and this over here is the motor for this conveyor belt. Alright, so that will be this, you'll see there is the one over there that says belt. That's the one that we'll be pushing to start it, and then I'll open up the box to show you what the contactor is doing. Alright, so here is the inside of that control box that you just saw. You can sort of see the DIN rail mounting in the back there. I'll zoom in on contactor number 3. That is the one that you'll see pulling in and out when I hit the start and stop buttons. These devices that you see at the bottom here, they are called thermal overloads, and we'll be covering them in a later video. But for now, just a quick explanation. When the motor is pulling more amps than what we have set the trip out on over here on the overload, that just simply means it will cut that motor off and it will stop it from running. Okay, the wiring inside this board is not really up to standard. In a future video, I will be building a new board for this particular machine. And have a bit of fun with it. We might do either a PLC, or we'll run it with an Arduino with a little bit of a display, so that you guys can also see how to do that kind of thing. Right, let me zoom into contactor number 3, and then we can take a look over there. So there we have it. We are now zoomed into contactor number 3, which runs the belt. As you can see, there is its normally open connection there. The normally closed is behind it. You can't see it. The control voltage on this particular panel is 380 volts, because there is no neutral in here. So when I press number 3, you can hear the conveyor running, and you can see that the contactor has pulled in. Then once I press the stop button, there I've pressed the stop button and the conveyor has stopped. Let's go have a look at another 1 or 2 examples. I'll just quickly start and stop this one again for you. And there we have it. Let's move on to the next example. Okay, so over here we've got another quick example. Inside that box over there, we have a direct online starter. That means there's a contactor inside there as well. When I press the start button, the magnetic coil is going to pull in, and it's going to start this machine up over here. There is a motor over there, which will start spinning. Right. Alrighty, I'm going to press the stop button. And now the coil is de-energized, and it's pulled out the contactor. Alright, so here we have another example. As you can see, there's quite a few contactors here. And here is one of the accessories that I was talking about. This is an extra auxiliary block that gives this contactor an extra normally open contact and an extra normally closed contact. All right, let me start this one up, and then you can see the contactors pulling in and out there. This will start a series of motors and that kind of stuff. Okay, so this contactor over here is the contactor for the main motor. It runs a hydraulic press. As you can see, that this machine uses different control voltages on its coils because there is a control transformer over here. Again, this is something that we will get into in later videos, but right now I just want you to focus on this contactor over here. Here we've got a normally open, normally closed, normally closed, normally open. So this is an auxiliary block on this contactor over here. Just another different example of what you will see or encounter in the field. And here is its thermal overload. Right, it's going to get a bit loud, but yeah, let's do this. Okay, now I'm going to start the hydraulic motor. And then as you can see that contactor has pulled in. I'm going to stop it again and you'll see it pull out. And then you can see, you could see it by over there, this little thing here, you'll see it moving, and that's indicating that contactor is pulling in and out. Let's do it one more time. Okay. All right, I think I've showed you guys enough examples of where we use these type of contactors in the field. There's obviously a hell of a lot more where we use contactors and things. There's a whole bunch in this machine to run and control a bunch of different components and that kind of stuff. Hey guys, I hope you enjoyed that video on the contactors. In the next episode, we're going to start looking at push buttons, start buttons, stop buttons, emergency stops, and after that, we're probably going to start looking at the overloads for the contactors, and we'll be slowly building up to starting to wire up our first control circuit, and we will take it from there. Thank you for joining me on this one. See you in the next one.